Warm greetings to one and all. In this session, let's learn about planning and planning agents. As a part of introduction, we all know that planning turns objective into actions to perform any activity effectively. Let's consider few real-time examples. Our mother will plan her day based on her family schedules. Yes, students plan their studies based on the exam schedule, subjects, and time availability. Let's consider the study planning. It always includes scheduling all the subjects, ordering the subjects, that is, which is to be studied first, that is subject A or subject B. Then constraints in planning for studies is number of days left for the exam, difficulty of the subjects, chapters to be studied in a particular subject, and notes availability for the subjects or chapters. And the final goal is to get pass mark or to get distinction in that particular subject or semester. Planning mainly helps us to decide how and when to do a task. And it has some steps to reach the goal optimally. Yes, without planning, we do exhaustive search to reach the goal. That is, like a problem solving agent, it tries every options in order to find the goal. So it is better to break the problem into smaller tasks. We can use heuristic search, that is smart guesses, in order to avoid wasting time. Planning mainly helps to solve the problem efficiently. We all know that planning a problem is about determining how to reach the goal state from the current state. It also involves deciding how and when to take a particular actions. It requires selecting and sequencing appropriate actions. Planning problem is defined by three components. Let's consider our example, that is study planning. So the first component is domain model. It describes the actions and objects involved. The objects involved are subject materials, time slots, and so on. And it includes operators that define the actions. The actions are study, revision, taking a quiz for a particular subject in a topic, and so on. Next, specifies action constraints and conditions. The condition are we can study only if that particular notes or resources available for a particular subject. The next component is initial state. The state before any action has been taken place. That is when an exam has been scheduled. The third component is goal state. So this state is mainly intended to achieve by the plan. For example, either I'm planning to get the pass mark or distinction, or I want to become a topper in the class. It also represents the desired outcome after all actions are completed. The planning strategy involves forming a plan. The sequence of action in the plan is also the part of planning process. So hope you are clear in planning problems. Now let's explore the components of planning system by considering the same study planning example as we have seen in the previous slide. The components are, first one is selection of best rule or action using heuristic, that is choosing an easier subject first based on the past experience or advice. The second component is taking action and applying the rule, that is studying the chosen subject to move ahead. We have to choose a subject and we have to read it well thoroughly until we understand it to reach the goal. Next, recognizing when the goal is reached. So we have to realize that we can now score more than the cutoff mark which we have targeted. Next, recognizing dead ends and handling it. That is, whenever we are getting stuck up in a hard topic that leads nowhere, we have to recognize it and we have to handle it such that we have to reach the goal. Next, recognizing partial solutions and improving. That is, doing well in all subjects except one, that is like mathematics or any other subject, and then adjusting the strategy in order to reach the full goal. So hope you are clear in components of planning systems. Now let's learn about basic planning representation. The main aim is to effectively plan. So for this, one must represent the problem very clearly. Planning representation involves a mapping of states, action, and goals. The language used for planning representation should be concrete, understandable, and expressive. The representation method can be varied. That is, it can be either propositional logic, first order logic, or it can be used in state variables. Planning components involve input to the planning, such as action, the possible activities that can be performed. Next, operators. Operators always define how actions change the states. That is, what are all the rules and conditions involved in it. Then, states. State represents the current condition or situations. The next comes planning process. It takes the input and processes them to create the plan. That is, planning takes the input from action, operations, and states, and then it creates the plan. The output from planning is goal. Goal is nothing but the final desired outcome. Then it has sub-goals. Sub-goals are nothing but intermediate targets that help achieving the main goal. The importance of time representation is required to reason about the actions and their effects over time. It also helps in decision making regarding the sequence and outcome of the actions. Now let's learn about state representation. Yes, the states represent the facts and are expressed as conjunctions of positive literals. The types of logic used to represent the state are, the first comes first order logic representation. Yes, it must be easily understandable. It requires grounding. That is, we are replacing the variables with constant. We should not use variables in first order logic. Instead, we have to use the constants. Let's consider the real-time example, that is a smart fridge which identifies the items which is available inside the fridge. So let's consider the first statement, that is inside fridge of milk and inside fridge of apple. So this first order logic represents that milk and apple are currently inside the fridge. The next statement is expire soon of yogurt and alert user of yogurt. So this first order logic represents that the yogurt is about to expire. So the fridge is alerting the user to use the yogurt before it gets expired. The third statement is low quantity of eggs and suggest restock of eggs. So this first order logic represents that the quantity of egg is low inside the fridge. So the fridge suggests the user to restock the egg inside the fridge. Now let's check out the grounding rule. Here we have not used any of the variables such as x and y. Instead, we have used all the predicates which are all fully grounded using the constant like milk, apple, yogurts and eggs. Now let's check out the closed word assumptions. So anything not explicitly stated is assumed to be false. If it is explicitly stated, then it is assumed as true. Only the specified states or exist in the world. If it is not specified means it does not in exist. The next type of logic used is propositional literals. For example, milk and apple. So it tells that milk and apple are available here. So it is used in simplified representations like strips. So strips is discussed in upcoming videos. So we can check out there. So we can either use first order logic representation or propositional literals in order to represent the state. Now let's learn about simple planning agents. A planning agent is one that plans its action using knowledge and problem solving. So now let's have a simple planning agent here. It has its own sensor to perceive the input from the environment, and it has its own actuators and effectors in order to do the action in the environment based on the perception. The agent has its own agent function in order to reach the goal based on the plan prepared by it. So the steps performed by the planning agents are, the first one is defining the goal. That is, an goal is initially set by the agent in order to reach the goal. Next, planning. That is, in order to reach the goal, a plan is built. Next, acting. So actions are invoked as per the plan in order to reach the goal by the agent. So this process continues each time with the new goals. Next, assumption made by the planning agents are, first, action occur one at a time. That is, no parallel execution should be done and the action cannot be further divided into sub-actions. Next, no uncertainty. That is, the agent is well versed with the outcome of each action. If this agent is performing an action in this environment, it should know what outcome will be there in this environment. Next, rules or things not specified are assumed to be false. If any rule is not specified, then it is assumed to be false. If any rules is being given, then it is assumed as true by the agent. Finally, the agent action causes the changes in the state and it has knowledge about it. If so, the environment is fully observable. So, hope you are clear in simple planning agent with this example. Thank you all.